There are a few situations where the numbers I've given so far won't be suitable, particularly under full load. It's important to understand your particular engine so you can apply a sensible AFR. Let's discuss that in some more detail with a few examples. First, let's assume we have a naturally aspirated engine that has been turbocharged. In this situation, often the peak boost will be kept quite low due to a high static compression and possibly to limit the amount of stress placed on the engine components. If, for example, we are running this sort of engine at 0.5 bar or 7 psi boost, I'd still choose to use a relatively rich AFR of around 0.80 to help control combustion temperature in an engine not designed for boost. Secondly, if you're tuning an engine fitted with a catalytic converter in the exhaust, we do need to be a little careful about our target AFR, as the cat may be damaged if the exhaust temperature is too high. In this situation, I'll address this by targeting a mixture 0.02 to 0.03 lambda richer at high RPM. I'll use the numbers we've already discussed up until about 2/3 of the engine rev limit, and then smoothly taper the mixture richer towards redline. This is the best we can hope to achieve without directly monitoring the exhaust gas temperature during operation. Another example, which is hopefully uncommon, would be a turbocharged engine fitted with no intercooler. In this case, the intake air temp is likely to be very high, and this can push the engine closer to detonation. In this situation, I'd choose to run the engine richer to help reduce combustion temperature. The actual AFR the engine responds to best will need to be found on the dyno, but it would not be uncommon to run as rich as 0.75 lambda. Lastly, we've been dealing solely with piston engines, and if you're tuning a rotary engine, we need to be aiming slightly richer than the targets we've discussed so far. At wide open throttle, a naturally aspirated rotary engine will perform well with a target lambda around 0.85 to 0.87, and in the transition area, a turbocharged rotary would want to see a lambda around 0.90. At medium boost, we'd want to be targeting around 0.78 lambda, and at high boost, approximately 0.75 lambda. You can see from this that you can't just choose a fixed number for the lambda that you will tune your engine to. You need to understand how the AFR affects the way the engine runs, and how the particular components on the engine may affect its requirements. This will give you the knowledge to make informed decisions on what to do. So, by the end of this section, you should understand the different operational areas of the engine and how to address each one. You should also understand how to select a suitable AFR. We can now move on and start applying this to the engine and actually tune it.